Yeah, we're live. And I'm 3 minutes early, which is awesome. Got some got a little bit of grape juice. Got a lot of cool things going on tonight. First of all, I want to talk about I just finished editing a video. I had lots of problems today for some reason with my editing software, and it was fighting me all day. So it did not want me to load this. And as it turned out, it was something odd. It turned out to be like a corrupt video file. So I kept trying to put this video file in, and every time I integrated it as one of the clips in this long sequence of the video that I have to put together and do the editing on, it decided that I don't like that, and I'm not going to allow you to upload that at all. So what I had to do, after trying to redo it several times, which takes a lot of time, if you guys know anything about editing, I actually had to delete that video, reshoot it, resend it, re-edit it, reintegrate it. So as you might imagine, that's somewhat of an all-day thing. So it's totally fun when it's not cooperating like that. Not that editing isn't a really, really long job anyway, but it was very cool. But the video that I'm working on that I will load, and I have another one right behind it that's also very cool on Honda stuff. Honda B series turbo stuff, and the power boost formula that I always talk about to show you how you can integrate that and how well it works. But this video on the intercooling is what happened during the Big Bang testing when I was pre-testing, getting the motor ready for the big TV thing that we did with the guys from Engine Masters, where we actually ran the motor on the dyno. What I did was run it at basically some lower boost levels, and didn't want to turn it up too much because we didn't know when it would break. As it turned out, it didn't break, which was even better. But I ran it at a bunch of different boost levels. And what we do initially while we're running on the dyno is, on these turbo things, is, especially with an air-to-water intercooler, in this case, it was the dual-core air-to-water intercooler that I use a lot on twin turbo stuff from the guys at CX Racing. And I've used this thing a lot over and over again on almost all the twin turbo stuff. But what we normally do is we'll just run it with what I'm calling ambient dyno water. And I say that because it's whatever the temperature of the big, I think it's a 2,500 gallon tank that they have, that whatever temperature that happens to be while it's feeding the dyno. And we don't have when we run it through the intercooler, we don't run it through the motor first. The motor gets separate water, and then the dyno gets just water feed off of the system. So in this case, it was about 78 or 79 degrees. And that can vary, because if you're in the summertime, if it's 95 or 100 degrees out, which it can easily be for a long time, the temperature of the water in the tank will heat up, and then it will start at a hotter temperature. If you make lots of runs, especially if you're making lots of runs that are high horsepower runs where you're putting a lot of heat into it, it can also bring the temperature way up. In fact, Westech has a big cooling system inside the facility that they got from some other facility, and it's got multiple fans on it and stuff, multiple cooling elements, and they run the water through there to get all of the temperature out of it, to make it sure, because you don't want to run it, apparently you don't want to run it through the dyno much if it gets up near 100 degrees. It's just too much. It starts causing problems with cavitation and stuff. But when we ran it, the temperature of the water, it was nice out. It was probably 65 or 70 degree ambient air temperature day, and then the water was about 78 degrees. And so the test was, I ran this thing at 14 pounds, and then all I did was we hooked up when I run the Big Bang, when we ran it for Engine Masters, or when I did any of the other ones, what I do is have a separate, in this case, it's a plastic fuel cell. It's a 10-gallon cell. And then we plumb all the water to and from that. And then that big cell with the big opening cut in the top, but allows us to just dump, endless bags of ice in there, so that we keep the ice water temperature, at or near 32 degrees or so. So we're constantly circulating this cold water through the air-to-water intercoolers, and then back out to be recooled off, basically, because we put enough ice in there to where the ice isn't melted for the various runs. We go through a lot of ice, unfortunately. And what I usually do are bring multiple coolers so that we can keep the bags of ice in the cooler. Westech has a they have a freezer, but it's not nearly big enough for me to have 20 or 30 bags of ice into there in addition to the other stuff that might be in there. So I have coolers that we put the stuff in, and that's part of the deal, is that if you're trying to run ice water, and especially it's more so if you're trying to do testing, if you're doing drag race runs, or like when we run at Bonneville, we'll keep all the stuff in a cooler and it stays for a long time if you have good coolers. And then we'll put it in our tank at Bonneville and put it in there and get ready, and we'll make a run. And there's usually in the 10-gallon cell, we'll put 13, 14, 15 bags of ice, how many ever will fit in there. And we don't fill it up with water. We only fill it about a third of the way up. The ice will melt. And also we want all of the cold into the water. You just have to make sure that you have enough water that it doesn't suck the system dry, and it doesn't, because we run it that way a lot. And so the ice lasts a long time. But when you're running testing on the dyno, it's easy to go through a lot of ice. But that's just part of the deal. That's part of the logistics of doing all the testing. So what we did was we ran the motor at that boost, same airfill, same timing, and then ran it again using ice water going through it. Now, a lot of guys, because they're so used to either OEM systems or closed loop systems, well, yeah, but it will add timing or it will change the airfill. No, it doesn't do that. We didn't allow it to do that. We don't give it that ability. It's run open loop, so it only does what we tell it. We have to manually adjust it to make sure that the run has the same air fuel. The timing does not change. So we made sure that we did that, and we did back-to-back runs with the different temperature. So in this video, I'm going to show you what the change in power was from the change in, obviously it's, we got colder air going into the motor. Although in this case, if you look at it, not very many systems might have a 2,500 gallon supply of 78-degree water going through their air-to-water intercooler. So in reality, it's really good already to begin with. If you're driving around, like when I had my Sprint and I had an air-to-water intercooler, and I had like a 2-gallon gas can, which I think was my intercooler, air-to-water intercooler reservoir. And then I had a circulating pump. Then I also had a heat exchanger up in the front. It looks like kind of like an oil cooler up in front of the radiator. And that system would maintain at or near ambient water temperature all the time, because you're not under boost a lot. So when you go under boost, the water would be whatever the ambient air temperature is roughly. Because and for a couple of good reasons. One is I had the heat exchanger out in front of the radiator, not in the engine compartment where it could heat soak. Also, the plastic container is a really good isolator of the water. If it were aluminum, like everybody likes to use, guess what? Aluminum is not a good isolator. It is a good conductor. So if you have a really hot engine compartment and you want to keep that water cold, all of that hot from the surrounding area is going to make its way through the aluminum, and it's because they're going to want to reach stasis. They're going to want to say, hey, look, I'm 200 degrees and you're only 100. So you're going to take some of my 200 and we're going to heat you up. And that's what happens. So instead of an intercooler, it's an interheater. So the Sprint actually worked very well, and we could drive around, but it was at ambient temperature. And so, that's pretty good. But with the water system on the dyno, we kind of have an artificially low temperature going through this, and we have an unlimited supply. Basically, there's no concern for, well, does it recover fast enough? Well, it's 2,500 gallons, so it doesn't really have to recover. So we're not changing it dramatically. We're changing it from 78-degree transfer medium to a 32-degree transfer medium, but we did see a difference. And so in the video, we talk about the difference in power, the difference in boost, and the difference in charge temperature. And then the question is, why did the boost change and why did the power change? And so when you guys watch that video, I want you guys to make sure that you comment and let me know why you think that there would be a difference in boost in that sort of situation. And then the other question, and that's the question for tonight, because we can talk about more than just the 6-liter turbo test, which I've run these air-to-water intercoolers. And I've run this standard ambient water versus ice water a number of times. I've run it on lots of LS motors. We've run it on big blocks and small blocks and Hondas, and ran it on my Bonneville car a number of times. I try to run it any time we run or planning on running ice water. We almost always run ambient water too, so that we can see what the gain is. And here's the thing that I can tell you: every time that I've tested this, when you put ice water in it, the motor really likes it. It sounds a lot better. And this is especially the case if we're testing like on a 100-degree day, where the water in the cooling system might be 90 or 95 degrees and the ambient air temperature is 90 or 95 degrees. And then so the temperature coming out of the turbo is going to be even hotter because the temperature going into the turbo is also very hot. So the more cooling that you can get, because you have reserve cooling in these situations, because when we did the test, we were only running about 14 pounds of boost. And, you know, as we know, that's going to be near double the power output, which we saw that. And it definitely did that. The other thing that's interesting is I show you the differences in the boost curves between the two runs. But in addition to just boost, I also show you the back pressure. And the back pressure on the on this big bang motor is very, very interesting because it's a lot lower than boost pressure is. And it was this way all the way up to 29 pounds. We had much less back pressure than we had boost pressure. And that's because we were using turbos that were oversized for the application. Even at 1,500 horsepower, we probably still had 500 horsepower worth of reserve flow in these turbos. And even though they were T4s, the twins, asking them to do what we were asking them to do, they were still, you know, pretty healthily into their efficiency range. So that's all good stuff. And what sent me down this path is I've been spending some time hanging out with my little 2.2 liter Dodge motor, which now, by the way, is on an engine stand. And I don't know if if you guys are not following me on Instagram, you should follow me on Instagram. I posted some short clips of what the freeze plugs look like in the blocks. And one of them was leaking really bad and there's rust all around it and stuff. The other one basically had holes in it. I want to take it out to see if the holes go all the way through, or if they've rusted up enough from the back that that they actually weren't leaking, even though they rusted through. It just makes me wonder about the condition of the block. I like the fact that when I was spinning this thing over for the first time, which I should have done when we were at the wrecking yard, I was just so excited that it said turbo on the valve cover that I had to have it. That was enough, even if I have to rebuild it. But it felt like for every cycle that it felt like all four of the cylinders had compression in it. So now I need to order one because I don't have one at my house. I need to order either a compression tester, which I will have to rig up the starter, which will be very interesting because to be able to rig up the starter, because it also bolts to the transmission, I only have the separator plate. So I'm wondering if a combination of me bolting the starter to the separator plate, and then the starter also has like a third bolt to it that bolts to the block. So I'm wondering if that would position the starter enough. And I think that the starter is going to locate inside the separator plate. You know, it's going to be an inside diameter thing. I wonder if that would be enough for the starter to engage to rotate this motor so I could do a cranking compression. If not, I can do a leak down because I have a compressor and stuff. We can do that here. I just kind of want to find out if this thing is a runner. And if it is, I might just run it the way that it is before I do anything to it. Because everybody tells me, oh, you got to put the 11 millimeter studs in. You got to change the head gaskets. You got to change the belt. You got to change all this stuff. Well, what I'm wondering is if this thing was running all by itself the way that it was. And if it was, and it's still happy, then I'll still run it until we need to do something. So at least I could get my first stage of testing done with it. And I have an interesting modification that I want to make. And I'm sure that somebody had to have come up with this before. The only reason that they wouldn't have come up with this or thought of this is because maybe they didn't have enough room. But if you guys know anything about these 2.2 liter Dodges, this non-intercooled version, basically the discharge from the turbo goes right into and this is a draw through throttle body. So the throttle body is in front of the turbo. So the throttle body opens and then the air goes into the compressor, and then the discharge goes right into the manifold, and the manifold is open. It has no throttle body on it, and it has a little turn in the manifold that connects just right at the turbo. So they're just connected by a silicone coupler, basically. So the problem is that I want to run an intercooler, but to be able to fit an intercooler in between those two things is very, very difficult. Even if what most people normally do is they will reclock the compressor housing on the turbo, which is easy enough. Even if I have to take it off, we can do that. But there's still not really enough room to get a discharge tube from the turbo to some kind of intercooler, which we mount on the dyno. That's very easy. But then getting another tube from the discharge side of the intercooler up into the intake manifold is difficult. But I think I figured out a way to do it. What I'm going to do is make an adapter that bolts to the factory exhaust manifold that will be flanged for the factory exhaust manifold, and then have another flange that's a duplicate of that with a tube in between it that's the right size, the same opening size as is in the manifold. And basically what we're going to do is just space the turbo away from the exhaust manifold. If we do, we're also spacing the turbo away from the intake manifold, and that frees up the room to get a tube to that inlet into the turbo, which will then allow us to run an intercooler on the non-intercooled version with the non-intercooled intake manifold, so that we're not making two changes at one time. Because it will be interesting to see what just the intercooler does with that manifold, which, by the way, is a just terrible design. So when we put a runner manifold on there, it's going to work out a lot better. But I want to see what this does, what the intercooler does with this setup, and show people what that does. And I don't think, judging by how much distance we need to make that spacer, I don't think that's really going to affect anything. Now, we are going to have to change. We'll have to adjust the tubes, like the drain, and this also has a water feed because it's a water-cooled center section. But all of that is just cutting and hoses, and all of that's pretty easy to do. That shouldn't be a problem at all. But if I can space that out and have it not affect the, it'll be, I wonder what it'll do to the response rate. It'll be kind of cool to test it. But the nice thing is I can make that that extension. I can have it, and the other thing that I can do once I do that is that will also allow me to run effectively any kind of turbo that I want, because it doesn't have to have that flange on it. It can have a T3 flange, which once I probably wouldn't do a T4, I don't think, on this little motor. I might eventually, but not with that manifold and stuff, only with the dedicated header. But I could make it like I make the others so that it's adaptable, and I could put a T3 on there. If I put a T3 on there, or I can do a flange that has both patterns on it. If I put a T3 on there, then the sky's the limit as to the turbos that I can test. I can run a max speeding GT3582 or a 3076, or even something smaller than that, and that would allow me to do quite a number of different turbos on this 2.2 liter. And where it's going to be positioned, you're going to be able to see the turbo on the dyno. So it will also look very cool because it'll be positioned right next to the manifold. So it could even be up high. I can get crazy and put a bend in it. I could do all kinds of stuff. But I'm just excited that would allow me to run an intercooler, whether it's an air-to-air, which I can do, or an air-to-water, which is easier to do on the dyno. I can do both and test them both. Naturally, we will also run E85 and stuff. And I think before we get too crazy with all of this stuff, that this motor is going to have to be gone through. And once we do that, we want to see, it's very common for these heads to have cracks in them, but I've been told not to worry about that too much. Eventually down the line, we want to do a ported head and cam and all of that stuff. So all of that will be interesting. But thinking about the spacing for the turbo, and then that allows me to run the intercooler. Then we went down this intercooler path, and then the same thing with the 6-liter deal. So let me know what you guys think. Do you guys think that the question that I posed on the thumbnail for this video is, do intercoolers add power all by themselves without a change in timing or without a change in boost? Does the change in charge temperature itself actually add power? So let me know what you guys think. Let's see. So I see people are making fun of Matt for some reason. Yeah, Robert, I agree. You can definitely feel the difference in power as the night falls. And where I noticed that more so than on other times was I had for many, many years, I drove a Vortex supercharged Mustang. I used to run at the Silver State, so we used to ring it out for all that it would do on top speed events and stuff. And when we would go out to Vegas on some of the races, it would be very cold out there. And it, when it's 100 degrees outside, the motor does not feel good at all. But when it's like 40 degrees outside, then all of a sudden the motor feels like it's intercooled, and it's a dramatic difference in power. And I wish I would have tested that on that little Vortec 302. It wasn't making a ton of power, but I'm sure you could see a difference. And I know that when we were running at the track, the few times that I did do drag racing, that we would ice the blower down and ice the discharge tube down, and it made a difference in mile an hour. It was worth a mile an hour and a half or 2 miles an hour when we would do that. So it was definitely helping out. Robert, even if I reclock the compressor, I don't think that the compressor housing itself will be out of the way enough to get to the inlet into that manifold. It might be, and maybe I find out that it's okay if we use a really small piece of tubing, but we'll see. And if not, then I'll do the spacer. Do you have any videos on L77? I don't think specifically on that motor, but all of the stuff should work. Flexall, what's the max boost you've seen on LS with a built motor? If that's directed at me, this 29 pounds is the most I've ever run. Julius, I don't know what the math would be unless you had actually run the two. And then if you ran the two and told me what like we did on the 4.6 4-valve motor on the 03 Cobra motor, we ran the blower and knew what boost it was producing, and then knew what to set the turbos up. And then I could tell you when we were running effectively 8 pounds from the blower and we were feeding the blower 7 pounds from the turbos, there was 21 pounds going in the manifold. Yeah. Mike, yes, the best intercooler is Canadian winters. I agree. When it's cold outside, it really loves it, especially if you actually have a dedicated cold air source so that you're grabbing ambient air outside of the engine compartment. Yes, everybody wants to use their air conditioning system for intercooling. That's a lot more difficult than people realize. The Dodge 2.2 had 2 different head designs, turbo and NA. Actually, it's more involved than that. The turbo motors themselves had different head designs, and they actually had 4 different head designs. They had two different 8-valve head designs, and then they had 2 different 4-valve head designs. Yeah, Charles has said Richard has shown that an intercooler is a good idea even at moderate to low boost levels. I like them for everything. I wish that I would have run an intercooler on the Vortec. Real early on when I had my Vortec, we tried an intercooler, but what happened on the Vortec is we ran a core that was probably smaller than it should have been, and the amount of tubing required it was a front mount air-to-air deal, and to get the amount of tubing required to run the core, we also lost boost from the blower. Now, we didn't turn the blower back up to get the same amount of boost, but it would have been better to do that. And especially with what I was doing, running, flat out sustained in the Silver State, getting that stuff, having a chance, you have an unrestricted amount of like a flow of air across the intercooler core would have been great. And it definitely would have kept charge temperature down. When I ran the Vortec out of the Silver State, we ran wide open throttle for like 7.5 pounds. The air temperature coming out of the blower was 135 degrees on a 75-degree ambient day, and we had cold air going to the blower. My ice tank with ice in it was worth 15 wheel horsepower on dyno and back-to-back tests. On what application was that, Spruce? What's the motor and stuff? I was impressed with your video of the 6. Which one? You got to be more specific. I got a Barra, I got a 4200, I got a 4.3 liter. Can you put the intercooler before the turbo? Yeah, you can cool the air before the turbo. The problem is you're cooling air that's already very cool. It's already ambient, but you're cooling air that's 300 degrees maybe coming out of the turbo, so you get a bigger change. What's the maximum boost on a forged internal aluminum LS6? We don't run the aluminum LS1, LS2, or LS3 motors much above 1,000 horsepower. The 5.3 stuff, like an L33, LC9, those kinds of things, seem to take a lot more boost than the other ones do. I think I think that the 1, 2, and 3 are thinner sleeves and stuff. Maybe guys have run more than that. We don't normally do that, so it's not a maximum boost for us. We look at as a power level, because this motor, like this 6-liter, would make 1,000 horsepower at like 15 pounds or something, or less than that, 14 pounds even. Yeah, 6 liters not hard to put together. They're pretty ordinary. Yeah, Julius, I don't think you spend a lot of time trying to math it out. You should put the blower on and make the blower make the kind of boost that you want, and then add the turbos. And then what happens is, the reason that like 8 pounds and 7 pounds didn't turn into 15 or whatever, I think it was I think 7 pounds and 11 pounds or something, is it was 18, and then the actual boost in the motor was like 21 or 22, and it didn't add up between the two. Because when you're blowing into the blower, all of a sudden the blower becomes a lot more efficient. It's a lot happier when you're forcing air into it rather than it's having to draw air, especially when you get up near the flow limit of the blower. If you can get past that part of it and blow air into it, it makes it a lot more effective. So the total boost in the manifold is going to be fairly high, which is the thing I really don't like about compound blowers, because I don't like to run high boost. I have always traditionally liked the most amount of power at the lowest boost level, but sometimes you can't do that. What is your view on intake charge, temperature drop, and pressure drop? You're going to have both of those. You have to. If you have air going through an intercooler core and you bring the temperature down, the boost is going to come down. It has to. It can't not do that. So if you lower the charge temperature by 100 degrees and you lose 4 pounds of boost, then that's a flow problem. But if you drop it a half a pound and you drop it 100 degrees, that's probably a fairly good trade-off. Nothing cools better than dry ice in an alcohol bath. Yeah. The problem with stuff like that is it's not very safe. It's a little bit volatile. No, Robert, it's not just the end tank design. It could be the size of the inlet and outlet. It could be the flow rate of the tank. It could be the flow rate of the core itself. It could be the amount of surface area that you have, the thickness of the core. It could be a lot of different things. I kind of want to see what a dry ice methanol intercooler, that'd be good, but again, it's not going to be very safe. Freiburger for me? I will. I don't see David that often. I send the messages and stuff once in a while. I just sent Dulcich a message because I asked him if he had an A100 Dodge truck. Because all of a sudden yesterday I was thinking, you know what I need in my life is I need a slant 6. A100 truck. And I thought that he had one, but I think he has a D100. Yes, Michael, the 6.0 is, as you get bigger, they obviously get better compared to the 4.8 and the 5.3. Michael's comment was, I was so impressed with the results of the video on the stock 6.0 NA compared to the 5.3 and the 4.8. It is. That's why I put the stock ones up there, because people were surprised that there was that much of a difference in power. I'm like, yeah, but just look at the rated power output. That's kind of what we would expect. But it's nice to see the actual dyno pulls. I kind of live for the dyno pulls. Jonathan, how much boost can you put on a small block Ford stock block stroke to 408? Well, a small block Ford, a 302 won't go to 408, but a 351 will go with tight ring gap. Maybe not, maybe 5, maybe 10. I don't know what tight ring gap is, and it just depends on how much temperature you're putting in there. And if I was doing a build, I would have ring gap in it, and I would do a 351. I wouldn't do a 408. And the only way that I would do a 408 is if I was doing something NA, or if it was something where I needed to make like 1,000,000 horsepower and it was a dedicated block and piston and all of that. The Mustangs were plenty fast before turbo LS swaps came in. A pro-charged big block might be an alternative to turbo LS, but if you're making 1,000 horsepower with an NA big block, it costs you more than a turbo in a 6-liter build. Again, people use the choice that, oh, well, this one's less expensive, so this must be the better thing. If that's your criteria, but that's not everybody's criteria. Some people already have a big block, and if you have a big block, you have a good starting point. It can make lots and lots of power. So can a Hemi, so can a Barra, so can a 4200. And so there's something to be said for doing the thing that you have. I mean, I understand that route. If I had a 4.62 valve, which I have, and we modified the heck out of it, and it's not the best thing to do because a 4 valve would be a lot better, or an LS. This is kind of pre-LS stuff, but you know, would be a better option. At least it would be less expensive, and you could get more power out of it ultimately. But a lot of guys had those. Hundreds of thousands of people had those 4.62 valve Mustangs. And so I wanted to show them, which is why I did the modular Ford book. I wanted to show them how to get more power out of the thing that they have. Same thing with a Chevy Sprint turbo. You could put an LS in it and it would be a lot faster, but it just wouldn't be the same. Have you ever boosted a 408 with 799 or 243 heads? It doesn't matter what the head is on that motor. We've made lots of 408s, but I don't ever remember running a 408 with a stock head on it like that. But you can boost those fine. We've run lots of stock heads with boost. What size S480 AR for a 460? Got to tell me the power output of the NA motor and then the power output of the combination you're trying to put together. If you only want 600 horsepower, then you could put a small AR on it. If you want 1,200 horsepower, then you could go with a bigger one. Yes, Mike, we understand you're pro big block. We get it. There's lots of other ways to make power. Big block Fords, LSs, turbos, all of that stuff. It all makes power. James, which 6-liter made 1,000 horsepower, 14 pounds? The video that I'm putting up right now, but if you take a look at the Big Bang motor, that's the one that made 1,000 horsepower at 14 pounds. Because it made what did it make? 548 NA. So the more power you start out with NA, it's easier to make power under boost. Mark, I'll let you know when I have information on the 4200. Julius, what I would recommend is letting the turbos do the. Julius's comment was that he's worried about the. He doesn't want to run any more than 14 pounds. I'm going to do the compound, but I may go back to just a supercharged engine. And you can run. I would run the blower at low boost and then have the turbos do most of the work. .400 wheel horsepower is a stock 6-liter, not an LQ4. It's possible, Dodgy Brothers. It is possible to make 1,000 horsepower without a turbo. It just needs a big motor. When's the next junkyard shopping spree? I don't know. I need to get, not till I get back down there. Casey, can you run Honda motors that run backwards? The reverse series stuff, for instance, is a good example. On the dyno, we could back when they had the 901. Now they have the 902s. They have directional vanes in the impellers, and we can't run the reverse rotation Hondas. Although they just got a Power Mark dyno, which if they put that in, then we will once again be able to run the B series stuff. Robert, the inline 5 is similar compared to the 4200. Dry ice and acetone, again, all of those things work. It's just that that's volatile, though. Is a V8 better than a V12? No, because 12 is more than 8, so it's got to be better. What turbo are you going to use for the 4200? We'll start with the GT45, and then we'll work our way up. Yeah, I think only the S2000 and then the K series stuff spin in one direction, and then all of the other ones, the D, B, and H stuff, spin backwards. Some people are still waiting for the stream to start. I don't think they make a 5-cylinder Barra, though. Joe, you should check out the wiki that Calvin did. He might have information on the 3500 and the 3700. Do I have any J series experience? Only on, we've run them on the chassis dyno, but not on the engine dyno. But it's one of the motors I want to put on the engine dyno, though. There's lots of Hondas making 1,000 horsepower. Turbo recommendation for a 331, 400 horsepower NA AFR. 185 forged rotating semi girdle on the block, looking for 600 wheel horsepower. Fuel injection. That's still, Edward, that's still in the range of the cheap GT45. The GT45 is sized pretty well for that. We ran it on the 302 and on the video is up. We run two 45 millimeters on ours on the dyno. I've seen guys try to go with smaller ones, especially smaller single ones, and they tend to have like they call it boost creep. It's just a rising boost curve. I've never seen a Weber intake for the 4.3 liter V6. Mike, Mike, who are you arguing with? Why are you so riled up? You need to relax. I have a 383 with an intercooler and a blow-through E85. Do you think a pair of 62s will supply enough air to hit 4-digit power levels? Yeah, the 62s would be enough for that. I don't know about the weight of how much does the 7.3 Godzilla motor weigh? I don't know. Have you watched Evan and Brian's stuff? Maybe they gave weights for those motors. What was the real reason Ford changed the cam firing order on the 5-liter motors? I would imagine it's for NVH. That's what they normally did. That they did it on the LS stuff for some sort of second or third order vibration, I think, that they were trying to cure. When are you going to do the 360? I'm only one guy. I can only test this a certain amount of times. I haven't done any Pontiac stuff. I have that one 347. I did the video on the 455 just because I happened to luck upon it when I was there, but I haven't ever even built one. I did do some testing way back with Robert Pond. He had an aluminum one that we ran stack injection on, but I can't find all the information on it to do a video. Otherwise, it's pretty cool stuff. Do you sell, auction, or raffle off your old test engines? Not normally. So Daniel's saying that he thinks that the 5-liter firing order was a bearing loading adjustment. Joel, so I'm trying to make 800 to 900 on my 6-liter LQ4. I was going to use a stock crank and have it balanced. Bore authority over, forged rods and pistons. How big a turbo should I go? Assuming you don't have to go through all that. Look at the video is already up actually on the Big Bang motor. 900 horsepower is not a problem. 800 to 900 is not a problem with the stock crank. You don't have to do anything to it. Forged rods and pistons are not a bad idea. If you're going to want to make that power, an S480 probably would be the turbo that you're looking at. Or the T6 S475 would do that much too, like the one that Summit has, the Borg Warner deal. Yes, Robert, there's nothing like free knowledge. So Ford changed the 302 firing order due to breaking the first main web on the newer, weaker blocks. See, here's the answer that I really like. This should become gospel from ECC. Ford changed the 5-liter roller firing order for better sound through the 2-chamber Flowmaster mufflers. Yeah, there's not a reason to bore the 6-liter. Charles is right, or no? Who said that? Yeah, Charles did. A 1,000 horsepower car on the street, especially on street tires, is a lot. Joel, you can donate here. You can do super chats. It's not mandatory, but it's obviously always appreciated. So I'm curious. I don't know if you guys saw the Instagram post that I made of the freeze plugs. This is pretty normal for something that was alive back in the 80s. I have no idea. This car, obviously, they got the motor from the car in California, but it could have been anywhere. It doesn't look like at least the engine, from the engine standpoint, luckily for it had oil leaks. So it kept everything, nice and lubricated. There's no rust. But I wonder about those freeze plugs and what the condition is of the cooling passages in and around the cylinders in that block. The nice thing for us is on the engine dyno, we're not running like flat out sustain. Like, this isn't a Silver State motor. So we can get away with a lot of stuff because we have, like I said, when we're talking about the intercooler stuff, if you have 2,500 gallons and it's 78 degrees, you kind of have an unlimited cooling capacity. So we can keep the motor as cold as we want it. We don't have to worry about overheating. But it just makes me wonder what else is going on with the motor. I'll know more once we do the leak down stuff on it, which will be very cool. Sometimes I just walk out there and I just look at it and walk around and talk to it. And I think I may even ask my son, who's been doing he's done some cool hydro dipping. I might have him hydro dip the valve cover on it just to make it look super fancy. Does anybody, ECC, I remember the commercial. Do you remember, does anybody remember the commercial with Deluxe 247? That is far and away one of my favorite commercials. You could take your breath away. It might be $5. Joel, it doesn't matter what it is. It just shows your appreciation and that you value all of the information that's going on here. Let's see. All the boosts. How big is the intercooler going to be? Is it a dual intercooler, single air to air, air to water? Are you talking about the intercooler that we used on the 6-liter or the intercooler that we used on the 2.2-liter Dodge? We talked about all of that tonight. So let me know what you're trying to ask. All the boost, which, by the way, good handle. And thank you again, Joel. Have you found that the 4.3-liter V6 puts down power in direct correlation to displacement with its V8 siblings? I think you kind of see that. If you look at the factory power rating of the 200 or so horsepower 4.3-liter Vortec V6, I think that's kind of in line with what the V8s of that period were doing. So I think it goes in line with that, and I think that's kind of what you would expect. If it has similar compression and cam timing and head flow, and it looks like the intake manifold is comparable, then I think it's probably right on. Jamie, I live in the desert. Our air is crap. It's hard to make huge dyno numbers, but yeah, you got that correction factor though. You need to move to Albuquerque where they have the 25 or 30% correction factor. you foresee being able to ramp up the Big Bang series? Well, the problem is I'd love to do all of those, except it's just me, and I'm the only one that, you know, gets these motors and redoes them if they need to be redone, and fixes them, gets all the parts, and does the dyno testing and does the videos and all that. So it's, you know, it's a lot of work. Mark's out. Let's see, how much boost will an all stock 5-liter HO take safely? I don't know about safely. I think we've run, I think when we ran about 12 pounds or so, maybe guys did more than that, but with the stock heads and all that, that seemed to be about where it was happy. I'm a follower of David Vivald. I think you mean David Vizard probably, and he's good stuff. The 215 Buick the 215 Buick Mickey Thompson Indy engine, that would be good. Yeah, CJ, what I'll do a lot of times on the dyno is, because I go get a wrecking yard motor and put it in, and I don't want all of the stuff from that wrecking yard motor to go into the water for the dyno. So what we'll do is we'll run water from the dyno into the motor, and then we'll put the out into big buckets and stuff, and that way it doesn't, all that rust and stuff, we try to get all of that out that we can. David Vivaldi. Ford Ranger in the Freedom Factory race. Did you ever check out Project Binky? What was that? What motor was that? David is good stuff. There's nobody that knows porting like that guy. What kind of compression would a flat top 6-liter with 706 heads be? That's going to be fairly high. That's going to be over 11. So, Sean, you think everyone's jumping on the bandwagon because it's a cam and block and it's a big bore? And is it the new 429 Super Cobra jet? Cameron's comment is, hey, Richard, another good video. I've been hearing lately that boring a 350 or 351/60 over can make them run hotter. Do you know if this is true? I've heard that too. I haven't specifically tested that either out on the street or on the dyno to see if that's actually true. But everybody that I've talked to, every machinist and every old school hot rod guy, they all tell me that it will definitely run hotter. Although I don't really understand the mechanics behind that though. I'm aware of Vivaldi, the classic music composer, but I thought that somebody was talking about David Vizard. Celica all-track engines, I do like those. Rex, thank you very much. It is the new 429 Super Cobra jet. I wish I could find an old one. All I need are the heads. How do they find a Celica all-track laying around, or the suspension and the subframe and the diff and all that stuff? Those things are really hard to find. Yeah, there's no reason you can't like the stuff that's going on here and the stuff that's going on with David. The thing that's great about the internet, and certainly about YouTube, is that everybody's doing something different. And so what I'm doing is different than what he's doing. And so there could be good stuff both places. Have you tested intake manifolds, one with a bent runner and the other with a straight runner? Actually, if they're the same length, I don't think you'll see any difference in power. Tom, I know Tom's got an all-track. The guy at Westech has one also. I'd like an 81 Mustang Cobra. Yep. Still have not found 429 Super Cobra jet heads. I saw one that were for sale for like $2,000. That's the only set that I found. I like the water wetter stuff. I've used that. I used the Redline stuff for a long time. I always ran it in my Mustang when we ran the Silver State. G Money, what are you doing there? Thank you very much. Project Binky is a mini with a Celica GT4 running gear. That sounds like right up my alley. Darren Morgan does good stuff. Again, another really sharp guy. And Steve Morris. There's a lot of good people out there. Bent versus straight runners. I can tell you it doesn't really change the flow rate very much. I will have a beer on you. I'll at least that. Is the ring gap that you prescribe for turboing NA engines relative to the piston diameter? Yeah, it turns out to be 6.5 to 7.5 thousandths per inch of bore, roughly, depending on how crazy you want to get. Would it work if you put 4.8 heads on a 6.0? Yeah, you can certainly do that. It's a 706 or 862 head, and you'd be putting on a 6-liter. The 6-liter typically will have 317 heads on it. Some of them will have 243 or 799 heads on them. Yeah, Sean, let me know if you have, even if it's something that we have to rebuild, that's not a big deal. And even if it's something I can borrow and give back, I don't necessarily care to have them. I just want to be able to build a duplicate motor and kind of run it. Robert, the formula is 6.5 to 7 thousandths per inch of bore. Casey, I don't know what would happen on the Quadrajet. I think most people that have ever run a Quadrajet in a blow-through application have housed it inside a they're not using a bonded on top of it. They're using a whole enclosure where everything has boost. So it will operate the same way that it does NA. I'll give you an L86 if you want to try some stuff. The guys over at Brian Tooley Racing have an L86 that we've done some testing with, and it's good stuff. It's like the LT1. It has a good intake manifold, and it's going to make it. That intake manifold, the long run manifold, makes more power than the L83 manifold does, and it makes more power than the LT1 manifold up to a given RPM range. It's your typical short runner, long runner kind of thing. I have not tested the Speedmaster cast iron small block forward heads. I'm sorry to hear, Dodgy, but should we tell them to get going so that... Thanks, Sean. I need to make some siblings for the 6.2, maybe a 5.8 liter, and then take one all the way out to 7 liters. Did you have any problems with the 24X reluctor wheel making big power on the LS? We ran the first three, the 4.8, the 5.3, and the 6.0. All of the Gen 3 stuff were 24X. And we ran those up to, some of them we didn't run very high in RPM, but we ran them up to, the 6 liter went up to 1482 before we heard it. Devin, I think you can run that LT1 with the right tune at that compression on E85, and 6 or 7 pounds would be fine. Rex, what are you doing? Rex is going crazy over here. Shift, I want to see some VVT cam swaps. Well, take a look at the stuff that I put up on the Gen 5 stuff that we did with Brian Tooley. There were some that we retained the VVT and kept it there. The 4200 obviously is doing VVT. We're going to do that on the Barra as well. Have you done any testing with an electronic wastegate? I have not. I do need to get a hold of the Turbo Smart guys. I know that Marty has one over there. I should probably be promoting that maybe and just testing it to see if it works. I know that it does. They do good stuff over there. My Nova is still in the same condition, although now I have a pressure washer so I can get some more of the dirt out of it. Robert, that's probably a better question for, so save that question and write it down. When I do a live feed with Brian Tooley, he probably can go into that a little bit more. I suspect what we're going to find is that this is typically what happens when people isolate things like that, valve diameter, curtain, and in its relation to cam choices and stuff, is it's not that cut and dry. It's like, okay, what's more important, lift or duration or lobe separation or overlap? You know, people want to pick one thing, and you can't always do that. Do you know the difference between the GT40P and the GT40? Yes, I do. And I like the GT40 better only because you're going to get similar performance between the two. And I like the being able to bolt the headers on and the plug angles and stuff. We need to compare the biggest VVT cam available to a similar spec non-VVT cam. I think if the intake duration is the same on the two, the VVT cam, if you can adjust it, is going to win. Unless you do variable cam with the non-VVT cam, which I don't know if you can do that, because if you can do that, then it's no longer a non-VVT cam. Julius, I don't know. Is the oil pan? Is there an oil pan gasket, or is it a receiver groove? And is it silicone that you put on there? I haven't even taken the pan off yet, so I'm not sure. Yeah, Mike, I would agree with you on that. I don't understand running iron heads on anything anymore. I don't even like lifting them up to flow test them. What were you finding on this intercooler test? I haven't posted the video yet. I'm done with the editing on it. So we ran the intercooler, and we ran with ambient water, and then we ran it with ice water. And then in the video, I'm going to tell you all about the change in charge temperature, the change in boost, the change in power, all of that stuff that happened when we did that test. But colder, just here's a spoiler alert, much colder air is much better. Question regarding balance. Had SCAT 383 pre-balance kit, mocked up, spun. I don't understand, Stephen. Mocked up, spun too much. Does that mean that you were spinning it by hand? The inserts were scarred. New inserts was 4 gram heavier. I don't understand what's happened here. Have you knocked weights out of it or something? $16 grams per throw is going to be a problem. CJ, did you, let's see, where's CJ's comment? Did you wear that shirt, my wrong cam shirt, because I put a TSP MS4 cam in my 4.8 liter? That's a lot of camshaft. I have run Texas Speed cams before, and I've reached out to them before, and I would be happy to test their stuff. Every cam that I've run from theirs has done what you would expect of a camshaft. It did well. Yeah, Mike, we're going to do more VVT testing with I did VVT testing NA with the 4200. We didn't do it under boost, but I will do it next time, and we'll try to figure out what's going on. The Gen 5 cams that we tested were in a 5.3, although Brian has also done 6.2 stuff as well. As a matter of fact, I should get with him tomorrow, and they have a 6.2 that's making some really big power. So it's it'll be a good video. I think that the VVT, if we can get comparable valve timing in a VVT, which I don't know that we can, because otherwise we won't be able to adjust it very far. What would probably happen is the VVT cam will make more average power, and then the cam that you could put lots of duration in is going to make more peak power. Robert, what's up? Thank you very much. Mike, who's your favorite? Apparently, I'm not at the bottom. So, Levi, I'm sure Tim's going to chime in on the S366, but I'm thinking that that's going to be 700 or something like that. How are the older cast iron Sportsman heads compared to newer heads? Or if you're talking about the Ford stuff, you know, they're okay. They're not great. They're better than stock heads, but I don't think that they're comparable to an Airflow Research or a like 11R head. Yeah, I don't know. There's something about the 2.2 turbo motor has an aluminum head. My 6-liter sloppy stage 2 cam, 100-pound injectors, backfires when lifting throttle, accelerating sometimes. Why do you have 100-pound injectors if you don't? Oh, you don't have the turbo in there yet. Okay. Yeah, it's probably a tune issue. They're not going to work. Well, they probably 100 pounds should be okay. Sean, the N52 would be cool. I like the BMW motors. So, Julius, it's an O-ring gaskets on the pan. You could take it on and off without concern. Okay. Some will argue you want heat in the chamber from the iron head. That's the old iron head, aluminum head deal, is it? You either run more compression because you have an aluminum head without detonation, or that you have to run more compression with the aluminum head because it dissipates all that heat. In my opinion, given how fast that happens, that in individual cycles, I don't think you see that. And when they've tried to test it at West Tech, the problem has always been getting an exact duplicate of an iron and an aluminum head, even though manufacturers that they've gotten these from have said these are identical heads. When you measure them and spec them out, they're not identical heads. So a new one will go up to 800. I told them 700, I thought, on the original stuff. Yeah, 700. CJ, some of them are spot on when you degree the cam. Some of them are spot on. The ones that I found were way off were the factory 4-valve and 2-valve cams. And they were not, I didn't find them off from centerline. I just found them off from each other. Yeah, Julius, the old 671s are like that. But then they were cog belts, so they didn't have to have a lot of tension. As a matter of fact, you didn't want to over tension them, so you could have the idler push the belt out basically, or you can have the tensioner push the belt in, which is more typical on these on a modern like a centrifugal blower or even the all of the root stuff. Oh, and see, now my connection's unstable. It's telling me it's time. Yeah, I did a test on, okay, this would be the last one. They're talking about intercooler piping, and I did a video on intercooler piping and what happened. As a matter of fact, there are a couple of them up there. One of them is where we changed the length dramatically, and we actually changed the size too, and it didn't have a big effect on boost response. And the other one did have an effect on power, though. That's where we were running a centrifugal blower, and we did a discharge tube size and the intercooler upgrade. So we had a restriction in the intercooler and the size of the tubing because the inlet and the outlet were a bigger size. So we immediately went up to that size tubing as well. So when we did that, we picked up quite a bit of power, and we picked up quite a bit of boost too, because the boost was basically stacking on the blower side of the intercooler and not getting into the motor. So once we freed that up, the blower could spin and push all of that air into the motor, and we made quite a bit more power. And the other thing that happened is, it should be noted that in this case, we were getting at or near the limit of the D1SE supercharger that we were at too. So it needed all the help that it can get. We were spinning it, fairly fast, and we were up at the 1,000 horsepower level, which is kind of where that blower is, it starts to run into limitations there. Thank you guys for showing up. I will see you guys all tomorrow. I need to load up this other video, so make sure to check it out on the twin turbo 6-liter. And I also showed the dyno results of us turning it all the way up, because that's what everybody wants to see. Thanks, guys. See you later.